Okay, so here we're going to be factoring binomials, and here I want to make sure that we know that these are special binomials. We're going to be factoring special binomials. Um, what's interesting about this one is that, again, I can't emphasize this enough. You always look for the greatest common factor first. But here we're going to be factoring some special binomials. So after you do the greatest common factor, you might be left with a binomial that has some really neat qualities. Now, with that being said, the type of factoring this is called, it's called difference of perfect squares. And I can't emphasize this enough. Difference. Difference is subtraction, right? Like sum is addition, difference is subtraction. So the pattern says that if I have two squares that are being subtracted, like a squared minus b squared, then it will turn into a plus b times a minus b. Whoa, there's a lot of just there's no numbers, Mr. Stevens. I'm having a hard time. And that's fine. What I need you to understand though is if I were to FOIL these out or multiply, so a plus b times a minus b. Let's see what happens. Let's just go through this exercise and see what happens. And maybe you'll notice that if you start at the end, you can get back to the beginning pretty quick on this one. This might be one of the easiest ones that we do. A times a is a squared. A times negative b is negative ab. B times a is a positive ab. B times negative b is a negative b squared. Negative ab and a positive ab go to 0, and you're left with a squared minus b squared. Well, hello. That's kind of the pattern I just gave you, right? All right, so let's do some examples. That's great, Mr. Stevens. That's real fancy, but how does this help me? Watch this. If I had something like x squared minus 16, I know that the factors is going to turn into a binomial times a binomial. The square root of x squared is x. The square root of 16 is 4. And it's a plus and a minus, and I'm done. Done. Let's try another one. What about x squared minus 81? Alright, well it's x and x, 9 and 9, plus and minus, and I'm done. Really, it's just that easy. Now, where you're going to see that this can cause a little bit of issue, here's where you're going to find this to be some trouble. What happens with that? So I have 4x squared minus 1. Well, the square root of 4x squared is 2x. Square root of 1 is 1. Alright? Okay, I'm with you. I'm with you. What about... Whoa, whoa, whoa. Why is there a y in there? Okay, hang on. This is not nearly as bad as what it looks. Here we have 25x squared. The square root of 25x squared is simply 5x. Square root of 49y squared is 7y. Plus, minus, I'm done. And that's it. Alright, let's try another one here. Let's get back to basics. Alright, the square root of x squared is x. The square root of 121 is 11. However, there's a plus sign. I cannot factor these. X squared plus 121 is not factorable. Right? And if a number or a phrase or expression is not factorable, we can simply say that it is prime. Okay, so if you run into one of these and it says x squared plus 4 or something like that, it is prime because of the plus sign.